Hey gang, so this is continuing on our trig chapter. This is section 3.1. So we're going to be looking at three-dimensional space. So think about it as xy and then, or xy here on this plane right here. I don't know if you can kind of see it right here, xy. And then going up, like if this was my paper coming straight up at you out of my paper, that's z. Z makes it into the three-dimensional part. So when we graph it, it is x, then y, then z, just like you would think it would be. So what we're going to do is we're going to write down the letters that coordinate to 0, 0, 0. So that would be right here. So I'm going to say that would be F. This would be x is at 2 and y and z are at 0. Here's your x-axis, here's your y-axis, and here's your z. So come out 2 on x, which are right here, and then you're not going anywhere else. So that's going to be A. Okay, so we're going to look at all the different vertices, and we're going to write them down and where the ordered pair ends up. So I guess I shouldn't say ordered pair, where the coordinate ends up. So we're going to do A through H. So we're going to write this. We're going to write A, B, C, D, E, F, G, let me see if I can squeeze it all on here, and H. Probably going to have to write those kind of small. Okay, so let's look at the ordered pair A. Well, we already did A. A was you came out 2, and then you didn't move again. Let's look at B. So B, remember you're always X first, so you're going to go 2 on the X, and then you're going to go over 1, this is 1, on the Y. And then I'm not going up any, am I? I'm just staying right here. So that means my Z ordered pair is 0. All right, let's look at C. So C is up here. So we're definitely going to have a Z. So on C, we're going to go up, let's see, how far are we going up? We're going up 2 on here. Then we're going to go over 1 on the Y. And then we're going to go up to 3 on the Z. We go over 2, 1, up to 3 to get to that ordered pair, or that coordinate. I keep saying ordered pair. All right, let's look at D. D is here. So we go out 2. We don't go y-axis at all. We stay right here. But then we do go straight up 3. All right, let's look at E. Oh, there's E. So on E, we don't do the x-axis at all. It's like we're right here. So we don't move on the x, but we do go out here 1. I keep thinking 2. 1 on the y, and then we don't go up any on the z, so that's going to be 0. Okay, F is, F is at 0, 0, 0. Where is G? G's up here on Z. So we're going 0x, 0y, and then up 3 on the Z. So 0, 0, 3. And then we have the H, which is over here. So on H, I don't do X at all. I go out 1 on the Y and up 3. So I go 0, out 1, and up 3. And there's that. So that's graphing in three-dimensional space. We're not going to do a lot of it, but you need to know how to do it because you will see that again later on. We'll graph some points. All right. So now we're going to do some more geometry. We're just going to do the midpoint of a line segment, and we're going to do the distance formula. These are exactly the same as they are in two-dimensional space. We're just going to add the z on here. So to find the midpoint, we average the x's, we average the y's, we average the z to find the midpoint. For the distance formula, we subtract the x's and square it, add it to subtracting the y's and square it, add it to subtracting the z's and squaring it. So those are going to stay the same. So here we go. If the endpoints of line segments are A and B, find the coordinates of the midpoint. All right. So I'm going to use the midpoint of AB equals I'm going to take the x's, which is 1 plus 2, and I'm going to divide that by 2. And then I'm going to take negative 1 plus negative 2, and I'm going to divide that by 2. And then I'm going to take 2 plus 3, and I'm going to divide that by 2, and that's going to give me my midpoint. So 1 plus 2 is 3, so that's 3 over 2. Negative and negative, that'll be a negative 3 over 2. 2 plus 3 is 5, so that'll be 5 over 2. And that's the ordered triplet, I guess. That's the coordinate for the midpoint of line segment AB. All right. The coordinates of the two of the vertices of a parallelogram, ABCD, are A is 2, 0, 0, B is 0, 0, 2. If the intersection of the diagonals of the parallelogram is M is 0, 2, 0, find the coordinates of the other vertices. Okay, so when you first read this, it's kind of like, wait, what? And I know I did kind of draw a picture over here. Here's what I'm going to do. If A right here is at 2, 0, 0, I'm just going to label these. B is at 0, 0, 2. And the midpoint, M, is at 0, 2, 0. Find the coordinates of the other two vertices. So we want to know these other two vertices. Well, I know that this is the midpoint of this segment, and it's the midpoint of this segment. So this would be X, Y, Z. And I could use X, Y, Z on that one as well. I'm just going to start with this one. If I add X and 0 together and divide it by 2, I actually get 0. So let's do the midpoint. Actually, I don't want to say midpoint. I want to say line segment. So let me do it this way. Make sure my notation's right. I want to say BD. So I want to say line segment BD. Okay. It's going to be, we're looking for the ordered pair D. Let's see. If I add X plus 0, this plus this, and divide by 2, that would give me the midpoint here. And then if I add Y plus 0 and divide by 2, that would be the Y coordinate. And then if I say Z plus 2 divided by 2, that would be this point. So the midpoint of line BD is this right here. But I know that this equals, I already know the midpoint, 0, 2, 0. So here's what I'm going to do. I'm going to set this one equal to 0, this one equal to 2, and this one equal to 0. I'm going to move this up a second while you guys are already working on that. Okay, so X plus 0 over 2 has to equal 0. I'm going to cross multiply, and I'm going to get X plus 0 equals 0, so X equals 0. So I know what the X value is. Then I'm going to say Y plus 0 over 2 equals the Y value. The midpoint of this line is 2. Cross multiply, so Y plus 0 equals 4, or Y equals 4. Then I'm going to do Z plus 2 over 2 equals 0. Cross multiply, so Z plus 2 equals 2 times 0 is 0. Subtract 2 from both sides, so Z equals negative 2. So that means that this ordered pair right here, let me get a different color, the X value is 0, the Y value is 4, and the Z value is negative 2. Okay, so I've got that one. I'm going to do the same thing, but now I'm going to use this ordered pair up here, C. So this one's going to be X, Y, and Z again. So we're going to use the same formula. So, but this time I've got segment AC. So the midpoint of AC is going to be X plus 2 divided by 2, Y plus 0 divided by 2, and Z plus 0 divided by 2. And I know that it equals my midpoint right here. which is 0, 2, 0. Same thing, we're going to set this one equal to 0, this one equal to 2, this one equal to 0. All right, so x plus 2 over 2 equals 0. Cross multiply, x plus 2 equals 0. Move the x over, I don't really have enough room, so x equals negative 2. Now let's do the next one. Y plus 0 over 2 equals, let's see. Oh, you know what? I put that in the wrong spot. I just now caught that. Man. So, oh no, I did that right, didn't I? I did. It equals, oh, it's just my handwriting. See, sometimes you have to have good handwriting. I'm gonna kind of do this so I don't mess that up again. This is what I'm working with. Okay. Y plus 0 over 2 equals 2. Cross multiply, so y plus 0 equals 4, and y equals 4. Z plus 0 over 2 equals 0. Cross multiply, z plus 0 equals 0, and z equals 0. So 0, 4, 0. I'm looking, did I miss a negative somewhere? Oh, no, I got it. Okay, so let me put it in pink again. So this one up here would be negative 2, 4, and 0. All right, so there's my missing coordinates that it wanted me to find. All right, so let's do number 3. Example, a remote-controlled drone is 500 meters north and 200 meters east of its operator, and it is 20 miles high. It is traveling due north at a constant height at a speed of 2 kilometers per hour. What will be the coordinate to the nearest meter after 30 minutes? 30 minutes is a half an hour because it's doing 2 kilometers per hour. At this time, how far will the drone be from the operator? Give your answer to the nearest meter. Okay, well, let's figure this part out. So remember when you graph, this is my y, this is my x. I guess I should have made that solid. This would be the y and the negative. And then x and the negative would, or z would be down here. So this is z. Okay, the remote control drone is 500 meters north. So 500 meters north, 200 meters east, and 20 meters high. So think about it as 500 north. We're going to go 500 north. We'll call that 500 north. 20 meters east. So it's going to go this way. We'll call that right there 20 meters east. And then 20 miles up. So then it's going up right here. So usually we draw it something like this. I'm not very good at drawing this. And it would be like right here out in space. So if I were to put that as an ordered pair, 500 meters north, 200 meters east, and 20 high. So that's my coordinates I'm looking at. I'm going 2 kilometers an hour, and I know that 30 minutes equals, I'm just going to do 0.5 of an hour. It's half an hour, right? Well, distance equals what? How do I figure this out? Distance equals rate times time. I'm going to kind of go slow and see if you can figure some of this out. I know that the rate is, we are doing, oh, you know what I didn't catch right here? Kilometers per hour, meter. Oh, we're going to have to convert, do a little bit of conversion here. So if it was 20 meters high, no, yeah, 20 meter, oh, it says meters. Okay, I'm going to check my units. Okay, I know what I was looking at. The 2 kilometers an hour would be I'm going to convert this, 2,000 meters per hour, right? So the time is half an hour and the rate is 2,000 meters per hour. So we're going to do 2,000 meters per hour and the time we're going is just half an hour. So this is going to be the distance is 1,000 meters that we're going to go in 30 minutes. We're not going to go very far. We're going to go 1,000 meters. Okay, then it says, at this time, how far will the drone be from the operator? Give your answer to the nearest meter. So due north is what we were changing, right? Because it said it is up here. Let me underline this. It says it is traveling due north at a constant height and speed of 2 kilometers an hour. So if we're going to travel 1,000 meters due north, then remember this is the north, this was east, and this was the height that it went. Basically what we are doing is we are traveling this direction due north 1,000 meters. So how is that going to change? Well, what that's going to change is it's going to move this 500 up 1,000. So we're going to be at 1,500. Everything else is going to stay the same. We're still going to have 200 at a height of 20. The drone, nothing else is changing. It's just going due north. All right. Well, now what it wants to know is something about the distance. At this time, how far will the drone be from the operator? Okay. Well, we know that the operator was right here where it started, right? So let's take the distance equals, remember distance is the square root. We've got our 2 ordered pairs, right? So we're going to do, let's do 1,500. I said that wrong. I was double checking. The operator is here. The remote controlled drone is 500 meters north and 200 meters east of its operator. That means the operator was at 0, 0, 0. So we're going to use that right there, the new one, and 0, 0, 0. So remember for distance, we're going to subtract these and square it. Plus 200 minus 0. I'm just putting this in as a formality so you kind of know where I'm getting these numbers. 20 minus 0 squared. So the distance is going to equal, I'm going to do all that in one fell swoop. Let me grab my pen or calculator. Okay. Here we go. So I'm going to do second square root, and I'm going to do 1,500 squared. Let's do 100 squared, 20 squared. All right. That means this is 1513.4067. Okay. It wanted me to do this, give your answer to this nearest meter. So I do need to take this and say that it's approximately, to the nearest meter would be right here. It's going to be 1513 because the 4 is not going to round up meters. That's the distance that it is from the operator now. How far will the drone be from the operator? And there it is. All right, I'm going to move on. All right, so the next thing we've got, that was just 3-dimensional space. Let's look at the next one, which is right pyramids, right triangle pyramids. And again, this is just more geometry. I'm not a big fan of geometry. Don't really care for the geometry. So anyway. All right, so here we go. Volume of a right triangle pyramid. So I'm hoping you can see this pretty well. There's a couple of things we need to know on this right here. The volume of a pyramid is 1/3 the base of the area times the height. Base area, so you got the base area times the height. Some things to know. The base down here, it's going to be a rectangular base. And you can kind of see that in the picture. It's a rectangular base. We can also tell that E is the apex. E's in the middle. Apex, whichever you want to call it. Probably the apex. G is the center of the base. And EG is perpendicular to the base. I'm going to put that up here, actually. EG is perpendicular to the base. those are just some basic things to note about a right pyramid, right triangle pyramid. Okay, if I were to take this and open it up, I wish I had like a picture I could show you, but if I took this face right here and opened it up, think about it like this over here, opened it up, and open the whole thing up, here it is without anything on it, it would look like this. So if I wanted to know the surface area, think about it like 1, 2, 3, 4, and 5. I would add the area of each one of those up to get the total surface area. So, surface area, it has 5 faces. 1, 2, 3, 4, 5, which you already labeled them, has 5 faces. And let's just, has 5 faces, and we're going to add them all up. So I'm just going to say it's 5 faces, and you add all up. You add them all up. And that would be your total surface area. The main thing is what it looks like. Okay? So I'm going to have questions I'm going to ask you about surface area, and we're going to have to try and muddle through and figure those out. Okay, so here's our volume. I'm going to highlight this. Volume of the pyramid, V. And here we go. Here's our first one. All right, so pyramid ABCDE is a square based as shown below. So here's this. The length of the side of the square is 12 centimeters. The perpendicular height of the pyramid is 8 centimeters. So I'm going to put a point right here. Find the surface area. So I need to know the whole surface area, right? So I need to find the surface area of the triangles, the 4 triangles, and the base. Well, the surface area of the base might not be that hard to find, really, right? Can we do the base? Yeah. So let's say the base is 12 by 12, right? That would be my surface area on that. Base is 12 by 12, so that would be 144. Okay, so that's the base. And if you remember, the formula we're going through is 1/3 the base area times the height. Okay, that's going to give us, that's the volume. Oh, that's the volume. I was sitting there. I'm doing the surface area. I didn't give you guys like an actual formula. I didn't realize that. Well, we're going to do the volume next. Maybe we should do the volume first. It might be easier to do. Okay, the height of this is 8, right? So yeah, let's do B first. Let's label this B. The volume is 1/3 the base area, which we thought was 144. The height, let's write that down. It gave us was 8. So the volume equals 1/3 the base area times the height. The volume equals 384. This is centimeters. It's a volume, so it's going to be centimeters cubed. All right. I like the volume. That one was easy to do. Okay, let's go back. Let's do some work. Let's see if we can figure out this area of all 4 of these. Well, in order to find the area, what I'm going to do is I'm going to come out here, this midpoint, and then I'm going to go up. Let's see if I can get up there to that point right there, right? Because this slant right here, we're going to use that slant because that's going right along the triangle, and that's going to help us figure out the height of the triangle so that we can figure out the surface area of triangle AED. AEB, sorry. My contacts are very tired. So I'm going to come over here. I'm going to switch colors. So I'm going to call this O right here. I'm going to draw this triangle right here. I'm going to call this E, O, and I'm going to call this point right here M because I know it's the midpoint. And I'm going to actually draw that triangle out here. This is my M. M to O, do I know M to O? Yeah, it's halfway, right? It's like halfway here because this is the center. If I come straight out and hit that midpoint, that makes this 6. I know that this right here is 8, and I know that that's a right triangle right there. So what I'm trying to figure out is the side ME. Well, I could figure that out, right? Because I could do A squared, B squared, C squared. All right, so here we go. A squared plus B squared equals C squared. That's going to be 8 squared, 6 squared, C squared. We're going to call this side C. So I'm going to just grab my calculator here. I'm going to do this. 8 squared plus 6 squared. I need it to, well, it's 100. I should have just done that, and then I would have seen that. C squared, square root of both sides. So C equals 10. Okay, so that means that this side over here is 10. Okay, that's going to be the triangle right here, right? If I take this triangle and pull it off, so you can see, I draw these because I'm super visual, and it helps me to see this is B over here, this is A over here, this is E up here. I just found the height of this I knew. Now, that's not 10. That is this line right here. Okay, that's this right here. So I just found that this is 10 right here. This is a right angle. This right here is a right angle. I know that this whole side right here is 12. So I know the height of this one now, because it was the hypotenuse of the other one. I know it's kind of hard to tell. So area equals 1/2 base times height, right? So I'm going to go back over here. I'll do this in green still. Area of the triangle, AEB, or however you want to write it, is 1/2 base times height, which is 1/2 the base, which is 12, times the height, which is 10. 12 times 10 is 120. Half of 120 is 60. And it's centimeters squared, right? Okay. Sorry, that's so crooked. I didn't catch that. So this triangle right here, which is this face, I found to be 60. Remember, how many of those do I have? I have 4. 1, 2, 3, 4. So 4 times 60 equals 240 centimeters squared. In order to find the surface area, I need to take the base area, right? The one rectangle, which we found the base area to be 144. And we need to add it to the surface area of all 4 triangles, which was 240. So that means my surface area is 384 centimeters squared. Well, that's interesting. The volume and the surface area are the same. There we go. That took 28 minutes. All right, so let's turn the page and go on to the cone. Okay, so the cone, the area of the curved surface of a cone is pi RL, where R is the radius, L is the slant height. Okay, so, oh, I did have that up there. I kind of rearranged this as I did it. I took some pictures away. The volume of the right cone is this, where R is the radius of the height. So I've got 2 formulas here that I'm going to use to help me on these. This is going to be the curved surface area. I'm going to highlight that. And this is going to be the volume of the cone. Okay. These problems to me are like, okay, I could have used my trig that I learned last class to help me solve some of these. But we're going to go ahead and do these. So the photograph shows a piping nozzle. So here we go. Which was used to apply icing into cakes and decorations manners. It is a curved surface of a cone, there is no base. All right, so meaning that this right here is hollow because you're going to put your icing in it, and then the little tip of it sticks out right here, and that's how you do all the writing and stuff. That's usually you use those to put the bags in. All right, so the piping nozzle has the following dimensions. The radius of the base is 15 millimeters. So look at this as I'm reading it. The base is 15 millimeters, and the radius of the top is 3 millimeters. So this is the top right here. It's kind of hard to see. But the radius, this right here, you can kind of see that 3 right here. That's a 3. Well, I don't think that really helped on y'all's. It's formed by cutting a small cone from the top of the larger cone. So see this right here, how it's going to be cut off. That's what this piece is. It's the cut off piece. The perpendicular height of the cone is 36 millimeters, and the perpendicular height of the cone that is removed from the top is 7.2 millimeters. Find the surface area of the piping nozzle, correct to 3 sig figs. Okay, so we're trying to find the surface area of this. That's the end goal. This is the same thing as this, except you're going to cut this little chunk off. The little chunk you're cutting off is this, and there's no, this is open down here. So we don't need the surface area of the circle because there's nothing there. All right, so we need to find the curved surface area of the larger cone. So let's just write what we're going to do. Let's find this, I'm going to say SA for surface area of large cone, of the large cone, so of the whole thing, of this whole thing. And then we're going to subtract this little small piece off of it. And then subtract the small surface, the small cone. This is a small cone. Find it of the whole thing, subtract the little one. So we need to find the area of this cone right here. The curved surface area of a cone, right, is pi RL. And I've got this little triangle here going with me. I'm not really going to use the volume. So here's what I'm thinking. I'm going to take this one right here. I'm going to break it out over here like such. And I'm going to see what I have. Let's see what I can figure out. I know this is a right angle here. I know that this side, the height from the base all the way to the top, this includes everything, is 36. And I know that this piece right here is 15. So I could figure out this side right here, and it's kind of different because of the way we're going to draw it. If I could figure out this, that would be helpful. So let's do our Pythagorean Theorem and let's figure that out. 36 squared plus 15 squared equals C squared. Okay, so let's see, 36 squared is 1,296. 15 squared is 225 equals C squared. 225 plus 1296 is going to be 1521 C squared. I'm going to take the square root of both sides. So C is going to be about, oh no, it's going to be exactly 39. Oh, that worked out nice. So this side over here is 39. All right, so I know that the area is pi times the radius times the length. L was the length. Or I'm sorry, L was the height. R is the radius, L is the slant height. And so I just found the slant height, or the length of the slant. I don't know if you call it the height, however you want to say that. Okay, so area equals pi RL. Area equals pi times the radius, which is 15, times the slant height, which we found to be 39. Now, I am going to put that in my calculator, and I am going to use pi. So, pi is over here on the caret top, second above the division bar, or the division number thing, times 15 times 39. All right, and area is 1837.831702. Okay, so I'm going to make a note here that this is the big cone that we just found. This is the big one. Now we need to do that same thing, but on the little cone. So I'm going to set that aside. And the little cone, I'm going to take this one over here. I'm going to draw it here. I know the radius on this one was 3. I know this height was 7.2. So I'm going to label this X, just so it's different from C. All right, and that's going to be my slant. And then I can find the area of this one, and then I can subtract it. So I'm going to write here small cone. Okay, so 7.2 squared plus 3 squared equals X squared. All right, I'm going to do all of that together. So 7.2 squared plus 3 squared equals 60.84. Take the square root of that. 7.8. So X is approximately 7.8. So this side over here is 7.8. Now, that means I can say the area equals pi RL. So the area equals pi times the radius times the length of the slant, which is 7.8. All right. I'm going to use my calculator, plug all that in, and I got 73.51. Now, I need to take, I'm going to highlight it, I need to take the area of the big and subtract off the area of the little. I'm going to cheat a little bit because I've already got these numbers in my calculator. So I'm going to go up here to the big one and say minus, and I'm just going to type that one in, 73.51. All right, so here's what I got. I'm going to say the area of the big minus the area of the small equals 1764.3217. And they wanted this to 3 sig figs. So that's 1, 2, 3. So 1760, and it is millimeters. It's area, so I need to make it squared. There we go. I feel like this unit's a little bit harder than the last one. I think the last one was super easy. This one I have to think about a lot more to really focus on it. Okay. So a solid cone has a slant height of 2 meters, a radius of 1.6. Okay, I know the slant, I know the radius. You want to know the area? I can give it to you. Find the total surface area of the cone in meters. Okay, let's draw this. So here's my cone. I'm not good at drawing these, y'all. Okay, there's that. That's a pretty sad looking thing. Okay, so I know right here, this to this. Okay, the cone has a slant of 2 meters, so I know this is 2 meters. The radius is 1.6. Find the total surface area. So the surface area, we're going to find the area of the circle, and then we're going to take the area of our cone. All right, so let's do the area of our cone first because we already know everything for this. So the area of the cone is going to be pi RL. So the area is going to be pi. The radius is 1.6 and the slant height is 2. I'm going to give you a second to work that. I'm going to leave this until I get to the end in terms of pi, and then we'll do our 3 sig figs at the end. So area is going to equal 3.2 pi. Okay, that's the area of the base, or the area of the cone. So now let's do the area of the base. That's the circle. So the area of a circle, hopefully you remember, is pi r squared. Okay, so that's going to be pi. The radius is 1.6. And we're going to square that. That's going to be our area of the circle. Maybe I could have this right here. I don't know if that helps you at all. See what I'm doing there? Okay, so this is going to be 1.6. So it's 2.56 pi. All right. In order to get my final answer, I need to take 3.2 pi and add it to this one, and then go ahead and get rid of the pi. So 3.2 pi plus 2.56 pi equals the total surface area. So here we go. 3.2 pi plus 2.56 pi equals 18.09. I'm just going to put 5. It wants me to give my answer to 3 sig figs. So 3 is going to be 1, 2, 3. So the 9 will round the 0. So it's going to be 18.1. And the units are meters. And I'm doing the surface area. So this will be meters squared. All right, example 8. A waffle ice cream cone has a diameter of 5 centimeters and a slant height of 12. Find the volume of the cone. Okay, well, I know the volume of a cone is 1/3 pi r squared h. And h is just the height of the cone. So let's see. I'm going to draw an upside down cone, y'all, because I can barely draw these as it is, let alone try and invert this and draw it the other way. Just pretend like the paper's been flipped. Okay, so what I know, and I'm going to change colors, I think that might help. I know that the diameter of the cone is 5 centimeters. So if I'm in the middle and I go out this way and all the way across this way, that is 5 centimeters. So half of 5, because the radius is only half of that, would be 2.5, right? And then when I go up, it gave me the height. The height was 12 centimeters, right? No, the height of the slant. That's the slant. So this is 12. It didn't give me the height. It just gave me, yeah, that's all it gave me. It gave me the slant and it gave me the radius, well, the diameter. So let's see what I know. The volume equals 1/3 times pi times 2.5 squared times h is the height, right? I don't know the height of the cone. Okay, so I'm going to have to do a little work. Man, I thought I could get away with this. Okay, come down, over, and I know the slant. So, I know that this is 2.5. I know that this is 12. And I need to know that height over there. Well, Pythagorean Theorem is probably going to be the easiest thing to do. I'm going to call this x. And I'm going to say that x squared plus 2.5 squared equals 12 squared. So x squared equals, I'm going to take 12 squared, which is going to be 144, and I'm going to subtract 2.5 squared. 2.5 squared, and it's 137.75. I'm going to take the square root of that. And so x is 11.73669459. And that's the height of my cone. So I'm going to take this number right here and I'm going to put it up here. So this is, I'm just going to do 3 sig figs, I think. 11.7. Now when I multiply it though in my calculator, I'm going to use this big number. So I'm going to say alpha y equals, because I love doing the fractions, 1/3 times pi, so I'm going to put pi there, times 2.5 squared, times, and I need to put this big number in here, so I'm going to go up, copy it down, 1/3 pi, 2.5 squared, checking it all. I'm going to hit enter, and I got that the volume is not the same thing I got last time. Okay, hold on, I'm going to double check my math. I just want to make sure. Nope, we got it right. I forgot to multiply it last time by pi. So we end up getting 76.81648646. And they wanted 3 sig figs, so the volume is 76 point. The 1's not going to do anything, so it'll be 8. And we are doing, oh, I'm sorry, I looked over here. It doesn't even say, I'm going to do 3 sig figs. Centimeters. Centimeters. Volume is cubed. I had it wrong on my notes. I'm going to correct it. 76.8. All right. Cones. I think that was it. Yep. All right. So we're at 45 minutes. I'm going to stop this video here. I feel like it's getting super long. I still have spheres to go to, angles between. Oh, I just have 2 more. Well, actually, I'm just going to keep going. Just going to keep going, y'all. I'll try and put markers on here so you know. All right. I know. Oh, look, another waffle cone. Okay. So here we go. The sphere and hemisphere. The surface area of a sphere is area equals 4 pi r squared, where r is the radius. The volume of a sphere is 4/3 pi r cubed, where r is the radius. Okay, so take a second, kind of look at those. We're going to do surface area and volume. These are all in your formula booklet. All right, so the plastic model of an ice cream. All right, let me get my paper so I can read it. I have to put it really close to my eyeballs so I can read it. You can read it. All right, so the plastic model of an ice cream cone comprises a cone with a height of 8 centimeters and a hemisphere with radius 4 centimeters. Calculate the total volume of the total surface area of the model. Give your answer correct to 3 sig figs. Okay, so let's take a look at this cone. Okay, it's a beautiful ice cream cone. What all do we need to find? We need to find the volume and the total surface area. So let's start with the volume. If I want to know the volume of the whole thing, I would need to find the volume of the cone and add it to the volume of the half of it, right? Half of the sphere, the hemisphere, right? So let's just write that out. We want to find the volume of the cone, and let's add it to the other volume, the volume of the hemisphere. All right, well, can we find the volume of a cone? Do we know that? So I'm going to come over here and I'm going to say the cone. The cone. Well, I know from before that the volume of a cone is 1/3 pi r squared times the height, right? That would be the volume of the cone. Do I know everything on it? Well, I'm going to take this and I'm going to kind of flip it around. And I'm going to draw it like this. Okay, that's a terrible cone. Okay. The middle of the cone up to the top, over to the side, and there's my angle. Okay, let's label what we know. The plastic model of the ice cream cone comprises a cone with a height of 8, so the height of the cone is 8. The hemisphere with a radius of 4. So that means the radius here is 4. Okay, in order to do the volume of a cone, I need to know that slant height right there, right? Well, let's do a squared, b squared, c squared to get that. So let's do 4 squared plus 8 squared equals c squared. So I'm just going to grab my calculator and do that. So 4 squared plus 8 squared equals 80. So the square root of 80 equals c. I'm going to leave that as the square root of 80, I think, for working with this. I think that will probably be a little bit easier. Okay. Let me pause. All right, so here we keep going. So the volume of our cone is 1/3 times pi. The radius is 4. And the height of our cone, I know we found the side over the slant, but we're going to use that in a minute. The height is 8. All right, so the volume of our cone. If we plug that into our calculator, 1/3 pi 4 squared 8. Alpha y equals 1/3 times pi times 4 squared times 8 is 134 point, I'm going to do 04. 134.04. All right, let's do the volume of the ice cream part, the hemisphere. All right, so the volume of the hemisphere we know is, the volume of a sphere, we did that one up here, 4/3 pi r cubed, right? 4/3 pi r cubed. The catch on this is we don't have a full sphere. We don't have the whole thing. We only have half of it. So I'm going to think about this, and I'm going to multiply this in half, or divide it by 2, whichever way you want to look at it. I only need half of it, though, because I only have half the sphere. So the volume, and we're looking at the hemisphere now, is I'm going to do 1/2 times 4/3 times pi times the radius, which in this case is 4 cubed. All right, so here we go. Alpha y equals, I'm just going to do oh, nope, I'm not. I'm going to do, okay, so I'm going to do this out of order, y'all. I'm going to do 4/3 times, I'll go ahead and do alpha y equals, just so I don't confuse you. 1/2, I switched the 1/2 and the 1/3. Pi times 4 to the 3rd power. 4/3 1/2 pi, yep. I'll put that over here a little bit so you can see a little better. All right, so there we go. So the volume equals 134.04. Again, they're the same. Okay. So the volume of the cone, I just need to add these together. So we'll call this volume total. How much ice cream can we put on here? 134.04 plus 134.04. The volume total, I'm just going to say total, equals 268.08 centimeters cubed. Give your answer correct to 3 sig figs. So this, 3 sig figs. The volume total would be 268 centimeters cubed. Now we have to do surface area. So the surface area, we need to do the surface area of the cone plus the surface area of the hemisphere. So I'm going to switch colors. Surface area. We're going to do the cone plus the hemisphere. All right. Let's put that there. For the cone, it's pi RL plus the hemisphere, which is 4 pi r squared. Okay, we know pi. We know the radius. We actually know the length of the slant as being the square root of 80 because we already did that math. So that's the square root of 80. I'll put that right there. Plus 4 times pi times r squared, which would be 4 squared. All right, we're going to, you know what? That hemisphere, the 4 pi r squared, that's the whole sphere. I need to do what to that? Since I only have half of it, I need to divide that in half. So I need to take this. I'm going to make that shorter. Could I have just changed the 4 to a 2? Yes, I could have. I would just want you to see the math behind that. Okay, so here we go. So we are going to do pi times 4 times the square root of 80 plus, and I'm going to do 0.5 because that's half of it, times, and then we're going to do 4, and yes, you could have changed that to 2, and it would have been the same thing. Second pi times 4 squared. I'm going to check my math. pi 4 square root of 80 half 4 pi r squared. 4 pi r, yep, I think that's right. So I got 212.928. So I'm going to put that over here. 212.928. And we are doing 3 sig figs. So this is going to be, the 9's going to round the 2 up, right? So 213 centimeters, it's surface area, so it'll be squared. And that'll be our total surface area. All right. Hopefully when I teach this live, it goes a little smoother. I feel like this is taking forever. Okay, a wooden spinning toy is made up of a cone and a hemisphere with a cylinder in between. All right, love geometry. Okay, the height of the cone is 4 centimeters and it has a base radius of 2 centimeters. What is the radius and the hemisphere? What is the radius of the hemisphere? Oh, well, this one won't be too bad. Okay, so a bunch of pictures here. Can you tell me, I'm looking for this distance right here, the radius of the hemisphere. This is kind of just a look at one and tell. All right, so I'm gonna start drawing, and okay, I'm gonna try to draw this around. Here's my cylinder. Some of you may already be going, it's 2. It is. It's, oh gosh, y'all, that's terrible. That is absolutely horrible. Oh, that's even worse. Okay. The wooden spinning toy is made up of a cone, of a hemisphere, of a cylinder in between. The height of the cone is 4 centimeters. So this is the height of the cone, and it has a base radius of 2 centimeters. So if the base radius is 2 centimeters, what does that make the hemisphere radius? Because it says what's the radius of the hemisphere. It's going to be the same thing. So it's going to be 2 centimeters. All right. There we go. That one was, I think, harder to explain until I drew it. All right. Hold on. Okay, example 10. In the diagram, the cuboid has the length of AB is 8. So let's see. I'm going to look at this here. AB is 8. AD is 3. And AL is 5. So this is 5. So you can kind of see I drew like a little triangle here. Calculate the angle between diagonal DB and LB. All right, so the angle, so we're looking for this angle here. All right, so in order to do this, we're going to figure out, like we can probably use a trig ratio. It's a right triangle, and opposite, this is the opposite side, which is 5, and this would be the adjacent side. But the dilemma is I don't know this, I'm going to highlight this. I don't know this length right. Okay, yeah, that one, very good. I don't know that. Can I figure out that? Yes, this is a right angle here, correct? So couldn't, and I kind of drew it apart over here. This is the base of the cuboid. So this is A, this is D, and this is B. Let's figure out that. So let's do 8 squared plus 3 squared equals, let's call this X. X squared. All right, I'm going to get my calculator out. I'm going to do 8 squared plus 3 squared equals 73. So I'm going to do the square root of both sides. So X equals the square root of 73. Well, if DB is the square root of 73, so DB is the square root of 73 right here, can I figure out this angle? Yeah. It's a right triangle, so I've got opposite over hypotenuse. So can't I just say that tangent of theta equals opposite, which is 5, over adjacent, which is square root of 73. Okay, remember when we did this the other day, if you're trying to find the angle, we got to use the inverse. So we're going to say inverse tangent of 5 over the square root of 73 equals. Let's use our calculator. When you're doing ratios, what's the one thing you always want to make sure you are in degrees? So check your mode. Make sure you've got degree highlighted. You are good to go. So we're going to do the inverse tangent. There it is. Alpha y equals 5 on top, square root of 73 on bottom. Oh, nope. Let me delete that, y'all. There we go. There it is. So it's 30.34. So that means that theta would be 30.3364. It wants it in, it doesn't give me it. So if it doesn't give me it, I'm going to assume it's 3 sig figs. Oh, that was bad. 30.3 degrees. Okay. I think this is cuboid. A, B, C, D, E, F, G, H. Has dimensions 8 centimeters, 6 centimeters, and 4 centimeters, as shown in the diagram below. So here we go. So we've got it drawn. Let me move this up a little bit. Oh, that is zooming in. Zoom it out just a little bit. There we go. Here we go. Calculate the angle between line segments FA and AE. So FA. So I want F to A. Calculate the angle between the lines FA and AE. Okay, so it wants this angle. Why didn't it just say angle A? It would have been a lot better. Okay, so take a look at that and see if you can kind of see what it's looking like. I'm going to come over here and I'm going to draw what I know. I know that this is F, this is A, this is E. I have this right here. All right. So what I know is that E to F is, let's see, E to F. Okay, hold on. I got to get my brain going around this. Do I know? You know what? Let me find, I think I need to find this AE right here. Because I'm looking at this triangle right here. And I think that's going to be the one. Okay, so I'm going to draw that triangle. Because I think that's the one that I want. Okay, because this is the angle I'm trying to find. So A, D, E. This, I'm going to kind of shade this in. It's so hard to see these. Okay, so that little piece right there. So I know that A to D is 8. I know that this makes a right angle right here. I know the height of this is 4. And this piece right here is the same side right here. So if I could find that, I know that this side right here is 6, right? E to F is the same as this right here. So that side is 6. I know that this is a right angle here. And I don't know the hypotenuse and I don't know this piece right here. So if I can find this piece, which is this piece, I'll have that side. Hopefully that made a little more sense. So 8 squared plus 4 squared equals, we'll call this x right here, x squared. So we're going to do 8 squared plus 4 squared is 80. So 80 equals x squared. Square root of 80 equals x. So this is the square root of 80. So this big side is the square root of 80. So to find that angle, let's look at what we know. We know the side opposite and the adjacent. So we're going to use tangent again. So let's use the inverse tangent of opposite over adjacent. Oh, 6 over square root of 80. So we got 33.85 33.545. So theta equals 33.8545. And we're going to do 3 sig figs. So theta equals 33 point. The 5 is going to round the 8. 33.9 degrees. I think that's calculate the angle between the, yep. So there we go. So 33.9 degrees. I think that might be a cognitive question, but I do not know for sure. All right. I believe this is the last one for, yeah, after this it's all cognitive. Okay, so calculate the angle between line GN and the base of quadrilateral ABCD. N is the midpoint of AD. Oh, that's really hard to see, y'all. Sorry about that. You can kind of see it right there. You can kind of see what you're trying to find. It's a little bit drawn here. So calculate the angle between line GN. So find line GN. That's this one right here. And the base of that. So I think what I'm going to do is just draw the line back right there. If I could figure out G, B out here to N. Oh, that, okay, that's just terrible. That's just a terrible drawing right there, y'all. That is just terrible. I'm going to do that. And if I could figure out G, N back to B, this angle right here is what I'm looking for. That's the angle I'm looking for. I know the height of this because when I look, it's 4. So I know the height of that is 4. I don't know BN though. I do know that this right here is 6. And I know that N is the midpoint of AD. So if this is AD, and if N's the midpoint and this is 8, couldn't I say that this little piece right here, AN, is 4? And this one would be 4. So I'm looking at this little triangle right here. I'm going to pull that triangle out. That is B to A, which is 6, to N, which is 4, to this one right here, which I don't know. And that right here, this BN, I don't know right here. That would give me that one. This would be a right angle. So let's just figure out what BN is. So we're going to do 6 squared plus 4 squared. I feel like we've Pythagorean theoremed this to death. X squared. All right. So 6 squared plus 4 squared is 52. Okay, so x equals 52, square root of 52 equals x. So that means Bn is the square root of 52. So Bn is the square root of 52. Okay, so to find that angle, we have the opposite and we have the adjacent. So let's do the inverse tangent of theta. Actually, not theta, sorry. I'm going to put the parentheses in there. Opposite over adjacent. So let's figure out what theta is. All right. Inverse tangent. We're almost done. Inverse tangent of alpha y equals 4 over second square root of 52. So theta is 29.0171 something something. We are going to do 3 sig figs, so 29.0 degrees. All right, y'all. If you're still watching this, I'm terribly sorry. You made it through. The rest of it is all the cognitive homework. Thanks for watching, y'all.